Good day, everyone. I am Frichel Herbias, the leader of Group 4. Along with my group mates, we're going to be discussing the Unit 4, which is the analysis and interpretation of assessment results. For the first presenter, let's have Ms. Rizal to discuss about the presentation.
So now, let us know first what is presentation. So presentation is a mode of conveying information to a selected group of people. So an ideal presentation is the one that identifies and matches the needs, interests, and understanding level of the audience. It also represents the facts and figures in form of tables, charts, and graphs and uses multiple colors. So presentation of data, on the other hand, refers to the organization of data into tables, graphs, or charts so that logical and statistical conclusions can be derived from the collective measurements. So as soon as the data collection is over, the investigator needs to find a way of presenting the data in meaningful, efficient, and easily understood way to identify the main features of the data at a glance using a suitable presentation method. Generally, the data in the statistics can be presented in three different forms such as textual method, tabular method, and graphical method. So let us know first what is textual presentation. So textual presentation, the data are presented in paragraph form. So this kind of presentation is useful when we are looking to supplement qualitative statements with some data. So for this purpose, the data should not be voluminously presented in tables or diagrams. It has just to be in a statement that serves as a fitting evidence to our qualitative evidence and helps the reader to get an idea of the scale of phenomenon. So out of the different methods of data presentation, this is the simplest one. You just write your findings in a coherent manner and your job is done. So the demerit of this method is that one has to read the whole text to get a clear picture. Yes, the summary, introduction, and conclusion can help condense the information. So here is the example of textual presentation. So there are about 540,000 Filipinos who joined the ranks of job seekers. So according to government data, the number of jobless Filipinos last July reached 4.35 million, an increase of more than 500,000 Filipinos from the same period last year. So the unemployment rate last July was 12.7% compared to 11.2% of July last year. The next one is the tabular presentation. So tabular presentation, the data are presented in tables to show relation between the column and row quantities. Tables are useful to highlight precise numerical values. Proportions or trends are better illustrated with charts or graphics. So the advantage of tabular presentation includes ease of presentation, ease of analysis, helps in comparison, and economical. To avoid the complexities involved in the textual way of data presentation, people use tables and charts to present data. So in this method, data is presented in rows and columns just like you see in the cricket match showing who made how many runs. Each row and column have an attribute such as name, year, sex, age, and other things like this. It is against these attributes that data is written with a cell. So the most significant benefit of tabulation is that it coordinates data for additional statistical treatment and decision making. So the analysis used in tabulation is of four types. So these are qualitative, quantitative, temporal, and spatial. So in qualitative classification, when the classification is done according to traits such as physical status, nationality, social status, and etc. It is known as qualitative classification. So quantitative classification, on the other hand, is the data that is classified on the basis of features that are in a quantitative nature. In other words, these features can be estimated quantitatively. So the next one is the temporal classification. So in this classification, time becomes the categorizing variables and data are classified according to time. time may be in years, months, weeks, days, hours, and etc. In spatial classification, when the categorization is done on the basis of location, so it is known as a spatial classification. So the place may be country, state, district, block, village, or town, and etc. So here is an example of the number of children has been divided between the male and female children based on both residence and 6 factors using tabular method. So age distribution of students in Cebu City Central School. So in this table, the data states the age of distribution of students in Cebu City Central School who are residents and non-residents in Cebu City. So in the first column, it states the age group of every student, followed by the male children that are residents and non-residents in Cebu City. So in the fourth column is the total number of male students, and in the next column are the female students with those that are residents and non-residents in Cebu City. And it is followed by their total number. Then in the last column is the overall total number of the female and male residents and non-residents in Cebu City. Now let's move on to the main parts of table. So the first one is a table number. Table number is the very first item mentioned in the top of table for easy identification and further reference. Next is the title. So title of the table is the second item that is shown above the table. Next is a head note. So head note is the third item just above the table and shown after the title. It gives information about units of data like about in rupees or dollars, quantity in tons, and etc. It is generally given in brackets. Next is the captions or column headings. So at the top of each column in the table is a column designation or head is given to explain the figures of column. So this column is known as caption. So next is the tabs or row heading. So the title of the horizontal rows is known as a tab. Next is the body of table. So it contains the numeric information and reveals the whole story of the investigated facts. Columns are read vertically from top to bottom and rows are read horizontally from left to right. Next is the source note. So source note is a brief statement or phrase indicating the source of data presented in the table. And last is a footnote. So this explains the specific features of tables which is not self-explanatory and has not been explained earlier. So for example, points of exception if there are any. So here are the main parts of the table.
Thank you for that, Ms. Giselle. And now let's go to graphical presentation. Graphics are pretty good for demonstrating a trend in the data do not be apparent in tables. It provides visual emphasis and avoid lengthy text description. The data are presented in visual form. It is a picture that displays numerical information. However, presenting a numerical data in the form of graphs will lose details of its precise values, which tables are able to provide. So the scores expressed in frequency distribution can be meaningful and easier to interpret when they are graphed. So there are methods of graphing frequency distribution. Examples are bar graphs or histogram, and frequency polygons and smooth curves. And now let's go to histogram. Histogram, it consists of a set of rectangles having bases on the horizontal axis which centers at the class marks. So the base width corresponds to the class size and the height of the rectangles corresponds to the class frequencies. Histogram is best used for graphical representation of discrete data or non-continuous data. So I have here an example of histogram. So using the frequency distribution of the 40 students in a 50-item mathematics quiz, and take note the value. And here's the sample histogram or histogram of the given data. And take note, as you can see in the table, the data in the x-axis is from the class mark and in the y-axis is the class frequency. And now let's go to the frequency polygon. It is constructed by plotting the class marks against the class frequencies. The x-axis corresponds to the class marks and the y-axis corresponds to the class frequencies. Connect the points consecutively using a straight line. Frequency polygon is best used in representing continuous data such as scores of students in a given test. The same examples of frequency distribution of 40 students in a 50-item mathematics quiz. So I have here the table or the graph, and take note, you can see that the x-axis is the x marks of the students or the score, and in the y-axis is the frequency. And now let's go to the quantitative analysis and interpretation analysis. So quantitative analysis and interpretation analysis refers to the process of examining and making sense of numerical data numerical data of information using systematic and objective methods. So levels of measurement in statistics and data analysis, there are four commonly recognized levels of measurement, which represents different ways of categorizing and descripting data or describing data. So these levels are hierarchical, with each level possessing the characteristics of the previous levels and adding additional properties. So according to Stevens, there are four levels of measurements: the nominal level or the categorical, and the next is the ordinal level or the ordered categorical, and third is the interval level, and lastly is the ratio level. And now let's go to the nominal level or the categorical level. This is the simplest level of measurement. Data at this level are categorized or grouped into distinct categories or labels. Nominal data have no inherent order or ranking. For example, jersey numbers in basketball are measured at the nominal level. A player with number 30 is not more of anything than a player with number 15, and is certainly not twice whatever number 15 is. And now let's go to the ordinal level or the ordered categorical. So data at this level can be categorized and ordered. So but the intervals between values are not uniform or meaningful. So ordinal data represents relative rankings or positions in ordinal measurement. The attributes can be rank ordered, and in here, distance between attributes do not have any meaning. So, for example, in a survey, you might code educational attainment as 0 is equals to less than high school, 1 is equals to some high school, and 2 is the high school degree, and 3 is equals to some college, and 4 is equals to college degree, and 5 is the post-college. And in this measure, higher numbers mean more education. So the interval between values is not interpretable in an ordinal measure. And now let's go to the interval level or the interval measurement. So in interval measurement, the distance between attributes does not have meaning. So data at this level are categorized, ordered, and have meaningful intervals between values. So interval data do not have a true 0 point, meaning that 0 does not represents the complete absence of the measured attributes. So examples includes temperature measure in Fahrenheit and degree Celsius, IQ scores, and standardized test scores. For example, when we measure temperature, the distance from 30 to 40 is the same as the distance from 70 to 80. So the interval between values is interpretable because of this. It makes sense to compute an average of an interval variables. So where it doesn't make sense to do so for ordinal scale. But take note that in interval measurement, ratios don't make any sense. 80 is not twice as hot as 40 degrees. And now let's go to the last level of measurement, which is called ratio. So this is the highest level of measurement and possesses all the characteristics of the previous levels. Ratio data have an absolute 0 point where 0 indicates the complete absence of the measured attributes. So this means that you can construct a meaningful fraction or ratio. Weight is also a ratio. For example, the number of clients in past 6 months.
Good day everyone, this is Amy Kisha Karian speaking, and for this part we're going to discuss about the measure of central tendency. So when we say measure of central tendency, it provides a very convenient way of describing a set of score with a single number that describes the performance of the group. So it is also defined as a single value that is used to describe the center of the data. It is thought of as a typical value in a given distribution. So there are three commonly measures of central tendency, and these are the mean, median, and the mode. So in this part, we're going to discuss how to compute the value and some of the properties of the mean, median, and mode as applied in a classroom setting. So first, let's start with the mean. So mean is the most commonly used and the most important measure of center data, and it is also referred as the arithmetic average. Mean is used if sampling stability is desired and if other measures are to be computed, such as standard deviation, coefficient of variation, and the skewness. So here are the formulas for the computation of the sample of the mean, population of the mean, and the mean for ungrouped data. So first, we have the formulation for population of the mean. So we use the Greek letter U, while for the number of the data values in the population, we use the capital N. So second, we have the formula for the sample of the mean. So we have X bar is used for the sample mean, X sub I or use values in the sample, X sub 1, X sub 2, X sub 3, and this symbol here, it means summation of the N is the number of the data values in the data set. So we have here example 1, compute the mean of the following scores of 15 students in a math quiz consisting of 25 items. So we have 25, 10, and 10, and so on. So we have here the solution. The mean score of the group of 15 students is the sum of all their scores divided by 15. So the mean therefore is 288 divided by 15, which is equal to 15.2. So this is the average score of the group. So now, for the analysis of it, the average performance of 15 students who participated in a math quiz consisting of 25 items is 15.2. So the implication of this is that students who get score below 15.2 did not perform well in the SAT exam, and students who got scores higher than 15.2 performed well compared to the performance of the whole class. So now let's proceed to the mean for group data. Group data are the data or scores that are arranged in a frequency distribution. Frequency distribution is the arrangement of scores according to the category of classes, including the frequency. Frequency is the number of observations falling in a category. The mean for group data can be computed in two ways, using the short method and the midpoint method. In the example, we are going to use midpoint method. So for this particular lesson, we shall discuss only one formula in solving the mean for group data, which is called the midpoint method. So we have here the formula where X is the mean value, F is the frequency in each class or category, X sub M is the midpoint of each class or category, and F is the summation of the product of Fx sub M. So now let's have the steps in solving mean for group data. So first, find the midpoint or class mark X sub M of each class or category using the formula X sub M is equals to lower limit plus upper limit divided by 2. And second, multiply the frequency and the corresponding class mark Fx sub M. Third, find the sum of the results in step 2. And then fourth, solve the mean using the formula. Now, we have here an example. So scores of 40 students in a science class consist of 60 items, and they are tabulated here. So we have here the summation of the product of Fx sub M, which is 1345 divided by N, which is 40, which result to the mean value, which is 33.63. So for the analysis of it, the mean performance of 40 students in a science quiz is 33.63. So those students who got scores below 33.63 did not perform well in the said examination, while those students who got scores above 33.63 performed well. So now let's have the properties of the mean that includes A. It measures stability. So mean is the most stable among other measures of central tendency because every score contributes to the value of the mean. And B. The sum of each score's distance from the mean is 0. It is easily affected by the extreme scores. And D. It may not be an actual score in the distribution, so it can be applied to interval level of measurement. It is very easy to compute. Now let's proceed to the median. Median is the second type of measures of central tendency. Median is what divides the score in the distribution into two equal parts. 50% lies below the median and 50% lies above the median value. Median is used when the exact midpoint of the score distribution is desired and if there are extreme scores in the distribution. Now let's take a look at these properties of the median. That includes, first, it may not be an actual observation in the dataset. B. It can be applied at the ordinal level. C. It is not affected by extreme values because median is a positional measure. So to find the median of the ungrouped data, first, we need to arrange the scores from lowest to highest or highest to lowest and determine the middlemost score in a distribution. So if n is an odd number, or get the average of the two middlemost scores if n is an even number. So for example, find the median score of 7 students in PE1 class with the following scores: 2, 10, 5, 19, 16, 17, 15. So to solve, arrange the score from highest to lowest. So we have here 19, 17, 16, 15, 10, 5, and 2. For the analysis of it, the median score is 15. 50% or 3 of the score are above 15, which is 19, 17, 16, and 50% of the score are below 15, which is 10, 5, and 2. So let's have another example. Find the median score of 8 students in an English class with the following scores: 32, 19, 15, and so on. So for the solution, again, we need to arrange the score from highest to lowest. So we have 30 as the highest and 2 as the lowest. And then get the mean of 15 and 16 by adding the two numbers and dividing the sum by 2. So the analysis of it is the median score of 15.5, which means that 50% of the score is in the distribution are below than 15.5. So those are 15, 10, 5, 2, and 50% are greater than 15.5, and those are 39, 17, 16, which means that 4 scores are below 15.5 and 4 scores are above 15.5. So we have here the formula for the median of group data, and here are the steps in solving mean for group data. So the scores of 40 students in a science class consists of 60 items and they are tabulated here. So the highest score is 54 and the lowest score is 10. Now solve for the median of the given score in the frequency distribution table. So we have here the solution. We have 34.5 plus 15 divided by 9. So we have 1.67 is equals to 36.17. So the median value is 36.17, which means that 50% or 20 scores are less than 36.17. So now let's proceed to the mode. The mode is the third measure of central tendency. Mode or a model score is a score or scores that occurred most in the distribution. So it is classified as unimodal, bimodal, trimodal, and multimodal. Unimodal distribution if it contains only one mode, bimodal distribution if it contains 2 modes, and trimodal distribution if it contains 3 modes, or multimodal distribution if it contains more than 2 modes. Mode can be used when the typical value is desired and when the data set is measured on a nominal scale. So the properties of the modes are, so it can be used when the data are qualitative as well as quantitative. So it may not be unique, it is not affected by the extreme values, and it may not exist. So for example, find the mode of the following ungrouped data. So we have 10, 9, 9, 7, 6, 5, 3, and 2, 1. So for the solution, the mode of the data is 9. Since 9 occurs twice, the distribution has only one mode, so it is a unimiddle distribution. And then find the mode of the following ungrouped data. So the solution for this is the mode of the ungrouped data is 17 and 16. Since 17 and 16 occurs twice, so the distribution is bimodal since it has two modes. Now for this example, scores of 40 students in a science class consist of 60 items and they are tabulated here. So for the analysis of it, the mode of the score distribution that consists of 40 students is 38 because 38 occurred several times. Again, this has been Amy Kisha Karyan. Thank you so much for listening. So to continue the presentation, let's have Ms. Herbias. Ms. Herbias, the floor is yours.
So thank you, Miss Amy. Now, let's proceed to the measures of variability. So the term variation is also known as variability, dispersion, or spread. So measures of variability is a single value that is used to describe the spread of the scores in a distribution or the spread of values about the mean. So unlike the central tendency that indicates where scores congregate, measures of variability simply tells us how spread out a group of scores are or how varied the scores are. Intuitively, a smaller dispersion of scores arising from the comparison often indicates more consistency and more reliability. So here are the most common measures of variability. We have the range, the mean deviation, and the standard deviation. So these measures are valuable tools for teachers as they provide insights into students' performance, help assess assessment fairness, identify outliers, set expectations, improve instruction, and contribute to data-driven decision-making in education. So let's have first the range. So range is simply the difference of the highest scores and the lowest scores in a set of data under consideration. So it is the simplest and the crudest measure of variation. So the properties of range includes first, it is quick and easy to understand because it provides a straightforward measure of the spread or dispersion of data. Second, it is a rough estimation of variations because it has limitations and doesn't provide a complete description of data. It is often used as a preliminary assessment before more advanced statistical analysis is performed. So third, it is easily affected by the extreme scores because it is based solely on the difference between the maximum and the minimum values. For teachers, this helps in understanding the variability in students' performance on assignments, tests, or assessments. So it allows them to see how different scores are from one another. So there are two types of group data, and in solving the range for ungrouped data, we have the range is equals to HS minus LS or highest score minus lowest score. And in getting the range for group data, we have range is equals to the upper boundary of the highest score minus the lower boundary of the lowest score. Let's try to solve first for the range in an ungrouped data. So again, the formula in getting the ungrouped data is R is equals to HS minus LS, where R is the range, HS is the highest score, and LS is the lowest score. So for example, there are two classes, Class A and Class B. The quiz scores for the students in Class A were 10, 12, 15, 17, 25, 26, 28, 30, and 35. And for the Class B, the scores were 15, 16, 16, 17, 17, 23, 25, 26, and 30. So find the range of the scores of the two classes. So here are the scores distributed in the table. So in getting the range for the Class A, since in the first column, that is the scores that are distributed for the Class A, and the highest score in Class A is, we can say it is the 35, and the lowest score is 10. So we just simply substitute the values on the formula. So the highest score is 35 minus the lowest score, which is 10. It is equal to 25. So the range in Class A is 25. And for the range for Class B, since the highest score in Class B is 30 and the lowest score is 15, so 30 minus 15 is 15. So again, the range of Class A is 25 and the range of Class B is 15. So for the analysis, the range of Class A, which is 25, is greater than the range of Class B, which is 15. So the implication of this is that the scores in Group A are more spread out than the scores in Group B. So it indicates that Class B, who have less range, suggests that students in the class perform more consistently, have similar skill levels, and grasp of the materials being taught. Hence, the teachers can plan lessons that are suitable for the majority of students without the need for extensive differentiation. On the other hand, Class A, who have a bigger range, indicates that the students in the class have varying levels of achievement. Some students are performing at a high level, and while the others may be struggling. Thus, the teacher should assess which specific topics students are struggling with and provide targeted interventions or additional support in those areas. Now, let's move on in solving the range of group data. So for example, find the value of the range of the scores of 50 students in mathematics achievement test. So here are the scores being distributed in a table. So in the first column, we have the range of scores, and in the second column, we have the frequency, or when we say frequency, it is the number of students who got scores that lies within the given range. So the formula in getting the range in group data is R is equals to the upper boundary of the highest score minus the lower boundary of the lowest score, where R is the range, HS sub UB is the upper boundary of the highest score, and LSLB is the lowest boundary of the lowest score. So before we can get the range for the group data, we have to get first the upper boundary of the highest score and the lower boundary of the lowest score. So the formula in getting the upper boundary of the highest score is UL, or the upper limit, plus 0.5. And in getting the range for the lower boundary of the lowest score is LL, or lower limit, minus 0.5. And as you can see in the table, the highest score is 89 to 97. And in this range, the upper limit is the bigger score, or the one on the right. And the lower limit is the lower score, or the one on the left. And since we only need the upper limit, so we get 97, then plus it with 0.5. So 97 plus 0.5 is 97.5. Now for the lower limit of the lowest score, in the formula we only need the lower limit, but first we determine the lowest score in the table. So the lowest score in the table is 25 to 32. And in this range, the lower limit is the 25. So we substitute 25 in the formula and then minus it with 0.5. So 25 minus 0.5 is 24.5. Now that we're done getting the upper boundary of the highest score and the lower boundary of the lowest score, we can now proceed in getting the range of 4D and group data. So we just simply substitute 97.5 and 24.5 in the formula, then solve. So 97.5 minus 24.5 is equal to 73. So for the analysis, the range of the 50 scores of the students is 73, which indicates that there is a spread of 73 points between the lowest and the highest final scores among the students, reflecting variability in their performances. Thus, this implies that the teachers may need to consider individualized or differentiated instruction. Tailoring teaching methods and materials to accommodate both high-achieving and lower-achieving students can help ensure that all students are appropriately challenged and supported. Now let's move on the mean deviation. So mean deviation measures the average deviation of the values from the arithmetic mean. It gives equal weight to the deviation of every score in the distribution. So to solve for the mean deviation, we still have two different formulas for the ungrouped data and the grouped data. So for ungrouped data, we have the formula mean deviation is equals to the sum of the absolute value of x minus x bar divided by n. And for the group data, we have the formula mean deviation is equals to the sum of the product of the frequency and the absolute value of the x sub m minus x bar divided by n. Let's have first the ungrouped data. Again, the formula in getting the mean deviation of the ungrouped data is mean deviation is equals to the sum of the absolute value of x minus x sub x bar divided by n, where MD is equals to the mean deviation value, x is the individual score, x bar is the sample mean, and n is the number of scores. So here are the steps in solving the mean deviation for ungrouped data. So first, we have to solve for the mean value first, and then subtract the mean value from each score. And the third step is to take the absolute value of the difference in step 2. And then lastly, solve the mean deviation using the formula MD is equals to the sum of the absolute value of x minus x bar divided by n. So let's take a look at this example. So find the mean deviation of the scores of 10 students in a mathematics test. Given the scores 35, 30, 26, 24, 20, 18, 18, 16, 15, and 10. So following the step from earlier, we have to solve first the mean value. And the formula in getting the mean value is x bar is equals to the sum of x divided by n. And to get the sum of x, we just simply add everything or all the individual scores in our table. So we got 212. So we substitute 212 in our formula. So 212 divided by 10, which is the total number of scores, we have, or we can get the value of 21.2. So for the second step, we have to subtract the mean value from each score. So since our mean value is 21.2, we just simply subtract the individual score to the mean value. So 35 minus 21.2, we get 13.8. 30 minus 21.2, we get 8.8. 26 minus 21.2, we get 4.8, and so on. So for the third step, we have to take the absolute value of the difference in step 2. So when we say absolute value, it is the non-negative value of the number. So for instance, we have here the negative 1.2. So the non-negative value of negative 1.2 is 1.2, or the positive 1.2. And negative 3.2, the non-negative value of negative 3.2 is positive 3.2. And so on. And for the numbers that are already positive, we just simply copy that. So for the first step, we have to solve the mean deviation using the formula. Since we're done getting the absolute value of the individual score minus the sample mean, we just have to simply add everything in the third column, and we get 60.4. So we just simply substitute 60.4 in our formula. So 60.4 divided by 10, which is the total number of scores, we get 6.04. And for the analysis, the mean deviation of the 10 scores of students in their mathematics test is 6.04. It indicates that though the mean deviation is not that big relative to the mean, we can still say that there is a variability in students' scores. Now, let's proceed in group data. So the formula in getting the mean deviation in group data, we have the formula mean deviation is equals to the sum of the product of the frequency and the absolute value of x sub m minus x bar divided by n, where MD is equals to the mean deviation value, f is a class frequency, x sub m is a class mark or midpoint, x bar is the number of scores, and n is the number of frequency. So here are the steps in solving the mean deviation for group data. So first, we have to solve the mean value. Next, subtract the mean value from each midpoint or class mark. Third, take the absolute value of each difference. Fourth, multiply the absolute value and the corresponding class frequency. Fifth, find the sum of the results in step 4. And lastly, we can now solve for the mean deviation using the formula for the group data. So let's take a look at this example. In a mathematics class, the scores of their achievement task for 40 students are grouped into the following intervals along with their frequencies. So find the mean deviation of the given scores in our table. So following the steps earlier, for the first step, we have to solve for the mean value first. So we have the formula sample mean is equals to the sum of the product of the frequency and the class mark. But before we can proceed, we have to get first the class mark. So in getting the class mark, we just simply add the upper limit and the lower limit, then divide it by 2. So for example, in our table, we have 10 and then 14 for the upper limit. So we get 24. Then divided by 2, it is equals to 12. So you can see it in the column 2 of our table. Next is 15 plus 9, it is equals to 34, then divided by 2, we get 17, and so on. Now that we're done getting the class mark, we can now proceed in multiplying it to the frequency so that we can get the sum of the product of the frequency and the class mark. So 5 times 12 is equals to 60, 2 times 17 is equals to 34, 3 times 22 is equals to 66, and so on. Now that we're done getting the product of the frequency and the class mark, we can now proceed in getting the mean value. So in getting the mean value, again, the formula is x bar is equals to the sum of the frequency times the class mark divided by n. So our sum of the frequency and the class mark is 1345 divided by 40, which is the total number of frequency. It is equals to 33.63. So the second step is to subtract the mean value from each midpoint or class mark. So since our mean value is 33.63, we just simply subtract it to our values in our midpoint. So 33.63 minus 12, it is equals to negative 21.63, and then 17 minus 33.63, it is equals to negative 16.63, and then 22 minus 33.63, it is equals to negative 11.63, and so on. So for the third step, we take the absolute value of each difference. So again, the absolute value is the non-negative value of the number. So the non-negative value of negative 21.63 is positive 21.63, and the non-negative value of negative 16.63 is positive 16.63, and so on. So for the first step, we have to multiply the absolute value and the corresponding class frequency. And for the fifth step, we have to find the sum of the results in step 4. So we multiply the second column and the sixth column. So 5 times 21.63, we have 108.15. 2 times 16.63, we have 33.26. 3 times 11.63, we have 34.89. After multiplying all the frequency and the absolute value of the class mark minus the sample mean, all we need to do is to add all the values in the seventh column, and we get 425.22. So for the last step, we can now solve for the mean deviation using the formula for group data. So again, our formula is mean deviation is equals to the sum of the product of the frequency and the absolute value of the difference of the class mark minus the sample mean divided by n. So our sum of the product of the frequency and the absolute value of the difference of the class mark minus sample mean is 425.22 divided by 40, which is the total number of frequency. We get 10.63. So, for the analysis, the mean deviation of the 40 scores of the students is 10.63, which means that the value deviated from the mean of 33.63 is 10.63. So that is all for the measures of variability. Now let's have Ms. Catherine Pipito to discuss about the variance and the standard deviation.
And now, let's begin with the variance and standard deviation. Variance is the variation about the mean. Variance is one of the most common measures of variations. It shows variations above the mean. It is a statistical measure that quantifies the spread of dispersion of a set of the data points in a data set. Standard deviation is the square root of the variance. It is the average distance of all the squares that deviates from the mean value. I have here here the formula of the variance for ungrouped data. We have the population variance is equal to the summation of the square differences between each data score and the population mean divided by the total number of the data scores in the population. And we also have the sample variance. Sample variance is equal to the summation of the square differences between each data score and the sample mean divided by the total number of data score minus 1. So next, I have here the formula of the standard deviation for ungrouped data. We have the population standard deviation is equal to the square root of the summation of the square differences between each data score and the population mean divided by the total number of data scores in the population. Sample standard deviation is equal to the square root of the summation of the square differences between each data score and the sample mean divided by the total number of data scores minus 1. And here's the steps in solving the variance and standard deviation of ungrouped data. First, solve for the mean value. Second, subtract the mean value from each score. Third, square the difference between the mean and each score. Fourth, find the sum of the result in step 3. Fifth, solve for the population variance and sample variance and population standard deviation and sample standard deviation using the formula of ungrouped data. And here is an example. Find the variance and standard deviation of the scores of 10 students in an English quiz. First step, solve the mean value of this data set. Let's use the formula of the mean for ungrouped data. So we have mean is equal to the summation of the scores divided by the total number of the data scores. So let's add up the data scores. 19 plus 17 plus 16 plus 16 plus 15 plus 14 plus 14 plus 13 plus 12 plus 10 is equal to 146. And the total number of the score is 10. So 146 divided by 10 is equal to 14.6. So our mean value is 14.6. Second step is to subtract the mean value from each score. So 19 minus 14.6 is equal to 4.4. So 17 minus 14.6 is equal to 2.4, and 16 minus 14.6 is equal to 1.4, and 16 minus 14.6 is equal to 1.4, and 15 minus 14.6 is equal to 0.4, and 14 minus 14.6 is equal to negative 0.6, and 14 minus 14.6 is equal to negative 0.6, and 13 minus 14.6 is equal to negative 1.6, and 12 minus 14.6 is equal to negative 2.6, and 10 minus 14.6 is equal to negative 4.6. And here's the difference between each score and the mean value. For the third step, we need to square the difference between the mean and each score. So 4.4 squared is equal to 19.36. 2.4 squared is equal to 5.76. 1.4 squared is equal to 1.96. And 1.4 squared is equal to 1.96. 0.4 squared is equal to 0.16, and negative 0.6 squared is equal to 0.36, and negative 0.6 squared is equal to 0.36, and negative 1.6 squared is equal to 2.56, and negative 2.6 squared is equal to 6.76, and negative 4.6 squared is equal to 21.16. And here's the square differences between each score and the mean value. For the fourth step, we need to find the sum of the results in step 3. So let's sum up the square difference between each score and the mean value. So 19.36 plus 5.76 plus 1.96 plus 1.96 plus 0.16 plus 0.36 plus 0.36 plus 2.56 plus 6.76 plus 21.16 is equal to 60.40. So the summation of the square difference between each score and the mean value is 60.40. So for the last step, let's solve the variance and the standard deviation for the ungrouped data. Let's solve first the population variance. Population variance is equal to the summation of the square differences between each data score and the population mean divided by the total number of the data scores in the population. So we have here 60.40 for the square difference between each score and the population value. And we have also 10 for the total number of the score. So 60.40 divided by 10 is equal to 6.04. So the population variance of the score of 10 students in an English quiz is 6.04. The analysis is the population variance of 6.04 indicates that on average, the square difference between each student's quiz score and the population mean 14.6 are approximately 6.04 square units. This measure quantifies the spread of variability of the quiz score in the entire population of students. And now, let's solve the sample variance of ungrouped data. Sample variance is equal to the summation of the square differences between each data score and the sample mean, divided by the total number of the data scores minus 1. So we have here 60.40 for the square difference between each score and the mean value. And we also have 9 for the total number of the scores. So 60.40 divided by 9 is equal to 6.71, and the sample variance is 6.71. The analysis is the sample variance of 6.71 is slightly higher than the population variance. The sample variance provides an estimate of the population variance based on the sample of 10 students. And now, let's solve for the standard deviation of ungrouped data. Let's begin with the population standard deviation. Population standard deviation is equal to the square root of the summation of the square differences between each data score and the population mean, divided by the total number of data scores in the population. So we have here 60.40 for the square difference between each score and the mean value, and we also 10 for the total number of the score. So 60.40 divided by the 10 is equal to 6.04. So the square root of 6.04 is 2.46, and the population standard deviation is 2.46. The analysis is the population standard deviation of approximately 2.46 indicates the average amount of variation of spread in quiz score for the entire population of students. It provides a measure of how individual quiz scores deviate from the population mean. And now, let's solve for the sample standard deviation of ungrouped data. Sample standard deviation is equal to the square root of the summation of square differences between each data score and the sample mean, divided by the total number of data scores minus 1. So we have here 60.40 for the square difference between each score and the mean value. And we also have 9 for the total number of the scores. So 60.40 divided by 9 is equal to 6.71. So the square root of 6.71 is equal to 2.59. The sample standard deviation is 2.59. The analysis is the sample standard deviation of approximately 2.59 is slightly higher than the population standard deviation due to the mesocorrection when dealing with a sample. It provides an estimate of the variation in quiz score for the sample of 10 students and is used to understand the spread of scores in the sample. Now, I have here the formula of the variance of group data. The population variance is equal to the summation of the product of the frequencies and square differences between each interval midpoint and the population mean divided by the total number of frequencies in the population. And we also have the sample variance. Sample variance is equal to the summation of the products of the frequencies and square differences between each interval midpoint and sample mean divided by the total number of frequencies minus 1. So next, I have here the formula of the standard deviation of group data. The population standard deviation is equal to the square root of the summation of the products of the frequencies and square differences between each interval midpoint and the population mean divided by the total number of frequencies in the population. Sample standard deviation is equal to the square root of the summation of the products of the frequencies and the square differences between each interval midpoint and the sample mean divided by the total number of frequencies minus 1. Here's the steps in solving variance and standard deviation of group data. First, solve for the mean value. Second, subtract the mean value from each midpoint or class mark. Third, square the difference between the mean value and the midpoint or class mark. Fourth, multiply the square root of the differences and the corresponding class frequency. Fifth, find the sum of step 4. Sixth, solve the population variance and sample variance and population standard deviation and sample standard deviation using the formula of group data. Here is an example. Score distribution of the test result of 40 students in a math class consisting of 50 items. Solve the variance and standard deviation. First step, solve the mean value of this data set. But in order to solve the mean value, we need to find first the midpoint of each interval or the class mark. To solve the midpoint, we need to add the upper limit and the lower limit and divide it by 2. So 15 plus 20 is equal to 35, and 35 divided by 2 is equal to 17.5. So 21 plus 26 is equal to 47, and 47 divided by 2 is equal to 23.5. 27 plus 32 is equal to 59, and 59 divided by 2 is equal to 29.5. And 33 plus 38 is equal to 71, and 71 divided by 2 is equal to 35.5. 39 plus 44 is equal to 83, and 83 divided by 2 is equal to 41.5. And 45 plus 50 is equal to 95, and 95 divided by 2 is equal to 47.5. To solve the product of frequency and a midpoint, let's multiply the frequency and the midpoint. 3 times 17.5 is equal to 52.5. 6 times 23.5 is equal to 141. 5 times 29.5 is equal to 147.5. 15 times 35.5 is equal to 532.5. And 8 times 41.5 is equal to 332. And 3 times 47.5 is equal to 142.5. So our summation of the products between the frequency and the midpoint is 1,348. And now let's solve the mean value. Let's use the formula of the mean for group data. So we have mean is equal to the summation of the products of each class interval midpoint and its corresponding frequency divided by the total number of frequency in the group data. So let's add up the data score. 1,348. And the total number of the frequency is 40. So 1,348 divided by 40 is equal to 33.7. So our mean value is 33.7. Second step is to subtract the mean value from each midpoint. So 70.5 minus 33.7 is equal to negative 16.2. And 23.5 minus 33.7 is equal to negative 10.2. And 29.5 minus 33.7 is equal to negative 4.2. And 35.5 is minus 33.7 is equal to 1.8. And 41 minus 33.7 is equal to 7.8. And 47.5 minus 32.7 is equal to 13.8. And here's the difference between each midpoint and the mean value. For the third step, we need to square the difference between the mean and each midpoint. So, negative 16.2 squared is equal to 262.44. Negative 2.2 squared is equal to 104.04. Negative 4.2 squared is equal to 17.64. 1.8 squared is equal to 3.24. And 7.8 squared is equal to 60.84. And 13.8 squared is equal to 190.44. And here's the square difference between the mean and each midpoint. So for the fourth step, we need to multiply the square difference and its corresponding class frequency. So 3 times 262.44 is equal to 787.32. 6 times 104.04 is equal to 624.24. 5 times 17.64 is equal to 88.2. And 15 times 3.24 is equal to 48.6. And 8 times 60.84 is equal to 486.72. 3 times 190.44 is equal to 571.32. So for the fifth step, we need to find the sum of the result of step 4. So let's add the result of step 4. So 787.32 plus 624.24 plus 88.2 plus 48.6 plus 486.72 plus 571.32 is equal to 2606.4. So the summation of the products of square difference and the corresponding class frequency is 2606.4. So for the last step, let's solve the variance and the standard deviation for the group data. Let's solve first the population variance. So population variance is equal to the summation of the products of the frequency and square differences between each interval midpoint and the population mean, divided by the total number of frequencies in the population. So we have here 2606.4 for the summation of the products of the frequencies and square differences between each interval midpoint and the population mean. And we also have 40 for the total number of frequency. So 2606.4 divided by the 40 is equal to 65.16. The analysis, the population variance of approximately 65.16 indicates the average spread of probability of test score in the entire population of 40 students. And now let's solve the sample variance of group data. Sample variance is equal to the summation of the products of the frequency and the square differences between each interval's midpoint and the sample mean divided by the total number of frequencies minus 1. So we have here 2606.4 for the summation of the products of the frequencies and the square differences between each interval midpoint and the population mean. And we also have 39 for the total number of the frequency. So 2606.4 divided by 39 is equal to 66.83. So the sample variance is 66.83. The analysis is the sample variance of approximately 66.83 is slightly higher than the population variance. And now let's solve for the standard deviation of group data. Let's begin with the population standard deviation. So population standard deviation is equal to the square root of the summation of the products of frequency and square differences between each interval midpoint and the population mean, divided by the total number of frequencies in the population. So we have here 2606.4 for the summation of the products of the frequencies and square differences between each interval midpoint and a population mean. And we also have 40 for the total number of frequency. So 2606.4 divided by 40 is equal to 65.16. And the square root of 65.16 is equal to 8.07. And the population standard deviation is 8.07. So the analysis is the population standard deviation of approximately 8.07 represents the average of deviation of test scores from the population mean. It provides a measure of how individual quiz score deviates from the population mean. And now let's solve the sample standard deviation of group data. So sample standard deviation is equal to the square root of the summation of the products of the frequencies and square differences between each interval midpoint and a sample mean, divided by the total number of frequencies minus 1. So we have here 2606.4 for the summation of the products of the frequencies and the square differences between each interval midpoint and the population mean. And we also have 39 for the total number of the frequency. So 2606.4 divided by 39 is equal to 66.83. So the square root of 66.83 is equal to 8.18. So the sample standard deviation is 8.18. The analysis is the sample standard deviation of approximately 8.18 is slightly higher than the population standard deviation. So in summary, the variance measure provide insights into the spread of probability of quiz scores. The population variance is applicable when you have data for the entire population, while the sample variance is used when you are working with a sample from the population. The slight difference between the two variances is expected when dealing with sample, and it reflects the sample's characteristic compared to the entire population. The interpretation of standard deviation. If the value of standard deviation is large, on the average, the score in the distribution will be far from the mean. Therefore, the scores are spread out around the mean value. The distribution is also known as heterogeneous. And if the value of standard deviation is small, and the average, the score in the distribution will be close to the mean. Hence, the score are less dispersed, or the score in the distribution are homogeneous. And that's all for the variance and standard deviation. And now let's call Miss Trisha.
We are down to the measures of relative position. So these are conversions of values, usually standardized tests to show where a given value stands in relation to other values of the same grouping. So the commonly used measures of relative positions are z-score, quartile, decile, and percentile. So the measure of relative position in statistics helps teachers assess student performance relative to the peers, enabling tailored support and data-driven decisions, fostering a more equitable learning environment. So let's proceed to the standard z-score. So when we say standard z-score, a z-score measures the distance between an observation and the mean measured in units of standard deviation. So the formula for the z-score is x, which is the standard's random variable, minus the sample mean over the sample standard deviation, or the standard deviation. So what is the significance of z-scores to teachers? So teachers can tailor their teaching method and materials based on the student's z-score to meet their specific needs, whether they need additional support or more challenging materials. And also, z-score can be used to explain student performance to parents in a standardized ways. So this can facilitate productive discussions between teachers and parents about student strength and areas for improvement. Now let's proceed to the standard normal distribution. So when we say standard normal distribution, it has the mean of 0 and a standard deviation of 1. So because of this, the standard normal distribution is centered at 0 and has intervals that are increased by 1. So each number in the horizontal axis corresponds to a z-score. So for example, the z-score of 2, so it tells us that the standard deviation from the right of the mean. And if the z-score is -3, it tells us that the standard deviation from the left of the mean. So remember that if the z-score is negative, so the score is below the mean. And if the z-score is positive, so the score is above the mean. Now, let's move on to the z-score negative and positive table. So, the left side is the z-score negative table and the one on the right side is the z-score positive table. So, this table tells us the total area that contain the left and right sides of any value in the z-score. So, for this table, the top row and the first column corresponds the z value, yes, and all the numbers in the middle corresponds to the area. So for example, according to the table, the z-score of -1.95, so negative, we look for the first column 1.9 and the top row 0.05, which has an area of 0.0256. Very good. For the application, so example, on the final examination in biology of grade 5, the mean was 75 and the standard deviation was 12. So determine the standard score of a student who receives a score of 60, assuming that the score are normally distributed. So the given Rx, or the standardized random variable, is 60 and the mean is 75 and the standard deviation is 12. So we're going to use the formula. So just substitute. 60 is the x minus 75, which is the mean, and which give us -15 divided by 12, and it gives us the number of -1.95. So therefore, the score of 60 is -1.25, standard deviation below the mean since it is negative. Understood? So it indicates that a score of 60 on the final examination in grade 5 biology is below the class average that falls -1.25 standard deviation below that average, suggesting that it is relatively lower compared to the overall performance, and it may signal the need for additional support or attention to help students improve their understanding and performance in biology. For example number 2, so in a science test of grade 5, test of grade 6, the mean score is 42 and the standard deviation is 5. So assuming that the scores are normally distributed, what percent of score is between 30 and 48? So the given are x, or the standardized random variable, 30 and 48, since the percent of the score is between 30 and 48 and the mean is 42 and the standard deviation is 5. So again, we're going to use the formula and just substitute. So we will solve the standardized random variable of 30 first. So substitute. 30 is x minus 42, which is the mean, is -12 divided by 5, and it gives us the answer of -2.4, and the equivalent area of -2.4 is 0.008. So you will look for the negative table I have presented recently. And next, we'll solve the standardized random variable of 40. And again, we will just substitute. So 48 is the x minus 42, which is the mean is 6 divided by 5, and it gives us the answer of 1.2. So since 1.2 is positive, we look for the positive table, and the equivalent of z-score 1.2 is 0.8849. So since the problem asked is what percent of the score is between 30 and 48, we will add the areas of the two z-scores, which are 0.0082 plus 0.8849 is equal to 0.8931, and multiplied by 100, the answer is 89.31. So therefore, in grade 6 class, there are 89.31% students who got a score between 30 and 30 to 48. Very good. So it indicates that in the grade 6 class, approximately 87.67% of the students receive scores within the range of 30 to 48. So this suggests that majority of students in the class performed within this score range, with relatively few students scoring either below 30 or above 48. So let us now proceed to the percentiles. So when we say percentiles, these are the scores points that divide a distribution into 100 equal parts. So therefore, the 50% distribution is equivalent to 50 percentile. So the median is equal to 50 percentile. So the middle value is the median of the distribution. So for example, you refer here, the 10% distribution is equivalent to 10 percentile, and the 20% is equivalent to 20 percentile, and so on and so forth. For example, Mrs. Carrido had a quiz in her Filipino class last Monday. So she recorded the test scores of 10 students, and the scores are as follows: 27, 29, 20, 28, 25, 25, 23, 30, 28, 24. So these are the steps in solving the percentile. So first, you arrange the values of the data in ascending order. So from 27 to 24, just refer here, we're going to arrange this from the small to biggest scores. So 20, 23, 24, 25, 25, 27, 28, 28, 29, 30. And second, we use the formula. PK is equal to K, which is the percentile rank, over 100 multiplied to N, which is the number of scores, plus 1. Substitute P20 is equal to 20 over 100 times 10 plus 1, so 20 over 100 times 11, so 220 over 100. So the 20th percentile rank is 2.2, which lies between the second and third score. So as you can see in the presentation, that 2.2 lies between the second and the third score. Third, since the 20th percentile lies between the second and third score, so interpolation is necessary. So in other words, if the answer is with a decimal, automatic interpolation is necessary. Understood? So interpolate the value to obtain the 20th percentile. So subtract the second data from the third data. So 24 minus 23, which give us the answer of 1. Very good. And we multiply the result by the decimal part obtained in the position of 20th percentile. So 1 times 0.2 is equal to 0.2. And again, we add the result to the second or the smallest number. So the smallest number is 23 plus 0.2 is equal to 23.2. Very good. So after interpolation, the 20th percentile for Mrs. Carrido's quiz scores is approximately 23.2. So this means that around 20% of the students scored 23.2 or lower on the quiz based on the provided data. So as teachers, this information tells us that among students who took Mrs. Carrido's quiz, approximately 20% of students scored at or below 23.2, suggests that there may be subgroup of students who are not performing as well as others on this particular quiz. For the second example, find the 30th percentile given the scores of 9 students in their science periodical test. So the scores are 45, 38, 35, 29, 54, 43, 42, and 38. And again, the first step we're going to do is arrange the data in ascending order or in lower to highest. So from 45 to 38, so 29, 35, 38, 38, 42, 43, 45, 54, 54. So second, we use the formula to find the position. So again, PK is equal to K over 100 n plus 1 and substitute. So P30 is equal to 30 over 100 times 9 plus 1. So 30 over 100 times 10. And 30 times 10 is 300 over 100. So the 30th percentile is in the third score. So the 30th percentile is 38. Very good, since the 38 is in the third score. Therefore, the 30th percentile is in the third score, and the third score is 38. So no interpolation is needed since the 30th percentile lies only on the third score. Very good. So this means that the 30% of students got a score of 38 and below. So in other words, 30% of the students who took the science periodical test received scores that were 38 points or lower. So it suggests that the majority of students, more than 70%, scored higher than 38 on the test. In computing the percentile rank, we use the formula where X is the score that you would like to determine the percentile rank, and N is the number of observation, frequency, students, data, or individuals. So, for example, Mrs. Rivera conducted a test for the third periodical exam. So find the percentile rank of a test score of 24 in the dataset. So these are the dataset or the scores provided here. Again, for the solution, first step is arrange the scores in ascending order. So 18, 20, 21, 22, 24, 29, 30, 30, 36, 40, 43, and 46. Second, we use the formula to find the percentile rank. So 18, 20, 21, 22, 24, 29, 30, 30, 36, 40, 43, and 46. So percentile rank of 24, so is equal to 4 plus 0.5 over 12 times 100. So it gives us the answer of 0.375 times 100. It's 37.5 or 38, which means that it's in the 38th rank. Therefore, in the scenario, the percentile rank of test score 24 is in the 38th percentile. So a score of 24 is below the middle score, which is the median in the dataset 30, and 38% of the students scored lower than 24, indicating that a significant portion of the students performed better on the exam than those who received a 24. So, as a teacher, this insight can guide us teaching strategies, helping us provide additional support to students who scored below the range and consider more challenging materials or enrichment activities for students who perform better than 24 score. So to learn more about quartile and decile, let us have Miss May Ashen Asibo.
Next is quartile. The quartile is the score points that divide a distribution into 4 equal parts. Each set of observations has 3 quartiles, which are denoted by quartile 1, quartile 2, and quartile 3. So how does this help analyze and interpret the assessment scores of the students? Using quartiles in educational assessment can be a valuable method for teachers to analyze and understand the distribution of scores within their class. Let's see this table. In quartile 1, also known as the lower quartile, represents the lower 25% of the distribution. Students whose scores belong to quartile 1 have relatively lower scores compared to the rest of the class. These students may need additional support to improve their performances. Now, in quartile 2, also known as the median, represents the 50% of the distribution. These students have scores that are in the middle. They perform neither significantly low nor high. Now lastly, in quartile 3, also known as the upper quartile, represents the upper 25% of the distribution. Students whose scores belong to quartile 3 have relatively higher scores and perform above average compared to their peers. Now, let us try to answer this or solve this problem. The following are the test scores of 15 students in a statistic class. Now, let us find the quartile 1, quartile 2, and quartile 3. So, our first step is we need to arrange the scores in ascending order. So, we have the numbers 0, 1, 5, 6, 7, 8, 9, 10, 12, 12, 13, 14, 16, 19, and 19. Now, in finding quartile, we need to use the formula QK is equal to K times the quantity n plus 1 divided by 4, where K is equal to 1, 2, 3, where 1 is for quartile 1, 2 for quartile 2, and 3 is for quartile 3, and n is the number of scores. So we have in quartile 1, our K is 1 and our N is again 15. So quartile 1 is equal to 1 times 15 plus 1 divided by 4. So 15 plus 1 is 16 times 1, 16. Divided by 4, we get 4. So quartile 1 is in the fourth data and the fourth data is 6. Therefore, the quartile 1 is 6. Moving on to quartile 2, our K is 2 and our N again is 15. So we get quartile 2 is equal to 2 times 15 plus 1 divided by 4. 15 plus 1 is 16 times 2, we get 32. Divided by 4, we get 8. So quartile 2 is the 8th data, which is the number 10. Therefore, the quartile 2 is 10. Lastly, in quartile 3, our K is 3 and our N again is 15. So we get quartile 3 is equal to 3 times 15 plus 1 divided by 4. 15 plus 1 is 16 times 3, we get 48 divided by 4. Our Q3 is 12. So quartile 3 is the 12th data, which is 14. Therefore, the quartile 3 is 14. Therefore, quartile 1 represents the lower 25% of the scores, which means that 25% of the test scores are at 6 or below. And quartile 2 represents the middle 50% of the scores, so 50% of the scores are at below or above 10.
and quartile 3 represents the upper 25% of the scores, indicating that 25% of the scores are at 14 or above. What happens if the rank that we get is not an integer? So let's try to solve this problem. The following are the test scores of 8 students in the science class, which are 33, 18, 24, 11, 59, 47, 61, and 72. Let's find the quartile 1, quartile 2, and quartile 3. Again, our first step is we need to arrange the scores in ascending order. So we get the numbers 11, 18, 24, 33, 47, 59, 61, and 72. In finding the quartile, we need to use the formula QK is equal to K times N, the quantity N plus 1 divided by 4. So in quartile 1, our K is 1 and our N again is 8. So quartile 1 is equal to 1 times 8 plus 1 divided by 4. 8 plus 1 is 9 times 1, we get 9. Divided by 4, we get 2.25. In the data, we do not have 2.25 rank, but we know that 2.25 lies in between the second and the third data, so 18 and the number 24. Therefore, we need to interpolate to find its value. The interpolation formula is QK is equal to LV plus the decimal times the difference of UV and LV, where LV is the lower value and UV is the upper value. So the lower value is 18 and the upper value is 24. We get that from our third and second data. So quartile 1 is equal to 18 plus 0.25 times 24 minus 18. 24 minus 18, we get 6. Times 0.25, we get 1.5. Plus 18, we get 19.5. Therefore, the value of 2.25 is 19.5. So our quartile 1 is 19.5. Moving on to quartile 2, our K is 2 and our N again is 8. So quartile 2 is equal to 2 times 8 plus 1 divided by 4. 8 plus 1 is 9 times 2, we get 18. Divided by 4, we get 4.5. So quartile 2 lies in between the 4th and the 5th data, which is 33 and 47. So we need to interpolate to find the value. So the interpolation formula again is QK is equal to LV plus the decimal times the difference between UV and LV. So the lower value is 33 and the upper value is 47. This data came from our 4th and 5th scores. So quartile 2 is equal to 33 plus 0.5 times 47 minus 33. 47 minus 33 is 14 times 0.5, we get 7. 33 plus 7 is 40. Therefore, the value of the rank 4.5 is 40. So our quartile 2 is 40. Lastly, in quartile 3, our K is 3 and our N is 8. So we get quartile 3 is equal to 3 times 8 plus 1 divided by 4. 8 plus 1 is 9 times 3. We get 27 divided by 4. We get 6.75. Quartile 3 is in between the 6th and the 7th data, which is 59 and 61. So we need to interpolate. We need to use again the formula QK is equal to LV plus the decimal times the difference of UV and LV. The lower value is 59 and the upper value is 61. So quartile 3 is equal to 59 plus 0.75 times 61 minus 59. 61 minus 59 is 2. And 2 times 0.75 is 1.5. 59 plus 1.5, we get 60.5. Therefore, the value of the rank 6.75 is 60.5. So our quartile 3 is 60.5. Therefore, quartile 1, representing the lower 25% of the scores, is 19.5. This means that 25% of the students scored 19.5 or below. And in quartile 2, which is the median, is 40. It signifies that the middle point with 50% of the students scoring below 40 or above 40. And in quartile 3, representing the upper 25% of the scores, is 60.5. This indicates that 75 of the students scored 60.5 or lower. In summary, the students in the science class have mixed performance. Half the students scored above the median scored of 40, while the other half scored below it. However, a majority of the class, about 75%, had scores at 60.5 or lower, suggesting that many students did not achieve very high scores. Next is decils. The decils are the values of the variable that divide a set of observations into 10 equal parts. Each set of observations has 9 decils, which are denoted by decile 1, decile 2, until decile 9. Decils help analyze assessment scores by showing who did exceptionally well, which is the upper decile, and who struggled, which is the lower decile, among the students. They also help identify the bulk of the students' performance, allowing to pinpoint those just below the top performers and understand how the majority of the students are doing in the middle. This information makes easier to evaluate and compare students' performance across range of scores. Now let us try to solve this problem. A teacher has recorded the test scores of 20 students in a mathematics class. These are the 20 scores of the students. Now we need to find the third and the sixth decile. So our first step is we need to arrange the scores in ascending order. So we have the numbers 58, 64, 66, 68, 69, 70, 71, 72, 73, 75, 76, 77, 78, 79, 82, 84, 85, 88, 91, and 93. So we need to use the formula to find the position. dk is equal to k times the quantity n plus 1 divided by 10. K represents the position of k quartile, while n represents the number of scores. So we have decile 3, we get 3 times 20 plus 1 divided by 10. 20 plus 1 is 21 times 3, we get 63. Divided by 10, we get 6.3. And decile 6, we have 6 times 20 plus 1 divided by 10. 20 plus 1 is 21 times 6, we get 126. Divided by 10, we get 12.6. So both rank positions need to be interpolated to find its value. To interpolate, we need to use again the interpolation formula. And third decile lies in between the 6th and the 7th data. So we have decile 3 is equal to 70 plus 0.3 times 71 minus 70. 71 minus 70, we have 1, and 1 times 0.3 is 0.3. So 70 plus 0.3 is 70.3. Therefore, the value of the 6.3 position is 70.3. So the decile 3 is 70.3. Moving on to the 6th decile. So decile 6 lies in between the 12th and the 13th data. So we have decile 6 is equal to 77 plus 0.6 times 78 minus 77. 78 minus 77 is 1. And times 0.6, we get 0.6. So 77 plus 0.6 is 77.6. Therefore, the value of the position 12.6 is 77.6. So our decile 6 is 77.6. Therefore, the third decile, about 30% of the students scored 70.3 or less on the test. So 30% of the students didn't do very well. While the sixth decile, around 60% of the students scored 77.6 or less. This includes the students in the third decile. So more students scored below 77.6 than above it. These decile values helps us understand how students did in the exam and where they stand regarding their scores. Deciles allow educators to identify high-achieving students, those in the top deciles, and low-performing students, those in the bottom deciles. This information can guide efforts to challenge high-performing students and provide targeted support to struggling ones.
So before we end our discussion, we want to leave you a quote. Assessment is not just about analyzing what students know, it's about interpreting that knowledge to drive meaningful learning experiences. So this quote emphasizes that assessment goes beyond merely identifying what students have learned. It underscores the importance of using assessment results to shape and design educational experiences that enhance students' learning and understanding, making the evaluation process integral to effective teaching and learning. And again, this has been the Group 4 Tackling Analysis and Interpretation of Assessment Results. That would be all, and thank you for listening.